You're here because you want to master mole and Avogado's constant with a University of Cambridge graduate. This is actually part 3 of our mole concept lecture series. If you want to watch our previous lectures on mole concept, or if you want to watch further videos after you're done with this one for mole concept, please be sure to check out our playlist or the link in the description below to watch these videos. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. Now we're going to talk about the mole, right? So what is mole, right? You must just understand that mole is just a physical quantity. It's like a measurement unit, right, in chemistry alone. And 1 mole of anything, right, any particle, any molecule, right, is equals to, there's actually 6 times 10 to the power of 23 amount of that particular particle, okay, inside. So this is also known as Avogado's constant, right? So for example, 1 mole of carbon dioxide gas, right, actually has 6 times 10 to the power of 23 CO2 molecules, and 0.5 mole of this has half of that. So there's actually 3 times 10 to the power of 23 carbon dioxide molecules. Okay, now remember this same number of moles, 0.5 mole of carbon dioxide gas, will actually have 6 times 10 to the power of 23 O atoms. Okay, because each molecule of CO2 will have 2 oxygen atoms, so you must times 2 from there. Alright, so how's this useful? We can actually use mole, right, and convert the unit of mole to like mass and a lot of other units as well. So for example, molar mass. Okay, molar mass by definition is the mass of 1 mole of atom of the element or molecule. It is equal to like the relative atomic mass or the relative molecular mass. So this is why we were talking about how to calculate relative atomic mass and molecular mass, because this is important over here. It links to moles. Okay, so you can use this rough formula. The number of moles actually equals to the mass divided by the molar mass itself. Okay, and this molar mass is the relative atomic mass or the relative molecular mass that you calculated, or you can calculate from the periodic table. So for example, right, if I want to calculate the number of moles in 64 grams of oxygen gas, right, we will just put a little notation. I like to put an N over here because this is a notation for number of moles, a very short form, right? And this equals to, right, 64 grams, which is the given mass, divided by the molecular mass of O2, which is 16 times 2. We found this from the periodic table, and this equals to 2.00 moles. We can leave our answers in 3SF. Right, let's look at the next example. Calculate the number of moles in 12.25 grams of barium nitrate. So how do we do this? Again, just write the formula of barium nitrate is BaNO3 right? And you want to find the number of moles, so you just take 12.25 grams divided by the MR of barium nitrate, which is 137 for barium, plus there's 2 nitrogens, so 14 times 2, there's 6 oxygens, so there's 16 times 6. And this will give you a value of about 0.0469 moles, right? Always leave your units inside as well, and put a little 3 sig fig if you did convert it, right? Okay, let's look at another example. So calculate the mass of 3 moles of chlorine atoms. So to find the mass of 3 moles of chlorine atoms, just a singular chlorine, okay, you now are given the number of moles. So we know that according to the formula, okay, that moles is equal to mass divided by molar mass. So if you want to find the mass, you will take the number of moles of chlorine times the molar mass. Oh, sorry, this is a singular atom, so this is actually atomic mass of chlorine. Alright, so this equals to 3 times 35.5. And this will give you a value of 106.5 grams. Of course, converted to 3 sig fig, right? So it's just 107 grams. Okay, let's look at another example. So calculate the mass of 0.2 moles of bromine gas. Okay, if they're talking about the bromine mass, right, this is just the mass of bromine, and this is in Br2 form, okay, because when we're talking about bromine gas, we're talking about the molecule, and these halogens exist as diatomic molecules. So the mass of bromine, Br2, is equal to the number of moles of Br2 times the MR of Br2, since it's a molecule. So it's just 0.2 times 80 times 2. Okay, and this equals to 32.0 grams over here, leaving 3 sig fig. Okay, final example, right? To find the mass of 0.6 moles of sulfuric acid, right? Sulfuric acid is H2SO4. So to find the mass of H2SO4, right, again, you will just take the number of moles, okay, times the MR of H2SO4, right? So we know it is 0.6 moles times the MR, which is 1 times 2 plus sulfur is 32 plus 4 oxygen 16 times 4. And this will give you a value of 58.8 grams. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.